yang baru pertama kali kesini, ini kan oke ya, berarti benar nih dikasih introduction dulu. Kalian ada yang udah pernah lihat ini belum? Logo ini? Udah. Sebelum datang ke sini nih, udah ada yang pernah lihat ini sebelumnya nggak? Belum pernah. Kalau yang ini udah pernah. Ya jadi ini emang baru, logo kita yang baru. Jadi dulu kayak gini, cuma warna doang. Sekarang kita punya agak sedikit filosofi di dalamnya, karena ada kayak ada protokol gitu. Jadi buat terus slice gitu. Jadi lebih merepresentasikan misi kita, karena misi kita adalah sebenarnya untuk ngejadiin internet, karena kita sebenarnya organisasi non profit. Jadi Mozilla itu bukan cuma perusahaan yang mengejar mengejar profit doang, tapi kita sebenarnya adalah yayasan di backup sama yayasan Mozilla Foundation. Jadi yang tujuannya adalah misi kita sebenarnya adalah buat bikin buat ngejaga agar internet itu jangan sampai jadi resource yang dikuasai oleh salah satu pihak tertentu kayak pemerintah atau salah satu perusahaan gitu. Jadi biar semuanya itu tetap gratis kayak sekarang, kayak pengetahuan yang ada di internet itu bisa diakses oleh semua orang kayak sekarang gitu. Tetap akan seperti itu sebenarnya gitu. Sebenarnya ini ada video, tapi karena nggak tahu dan ini daripada kelamaan. Nah, untuk melindungi web biar nggak ada orang yang menguasainya gitu. Nanti bisa dilihat sendiri misi yang lebih lengkapnya dan macam juga. Nah, karena kita produknya itu banyak gitu. Jadi kita banyak dibantu juga sama volunteer di banyak negara. Jadi ini salah satu wujud kerjasama kita. Jadi biasanya kalau misalkan kita ngadain meeting, jadi di Mozilla ada meeting setiap 6 bulan sekali. Nah itu juga biasanya volunteer diundang sini buat ikutan kerja bareng gitu. Nah di Indonesia sendiri kita ada komunitasnya, namanya komunitas Mozilla Indonesia. Nah kegiatan kita biasanya ngadain kelas kayak gini nih, ngadain kelas tentang teknologi, tentang gimana sih cara kita biar tetap aman di internet, karena internet kan sebenarnya bisa jadi celah tersendiri biar dimanfaatkan orang lain kan. Nah kadang kita bikin kelas gitu juga. Nah kalau kalian pengen gabung nih sama kita, gimana sih cara kalian kontribusi ke Mozilla? Nah kalian bisa lihat sendiri nih di mozilla.org/contribute. Meskipun itu nggak terlalu update sih, nggak terlalu update kontennya yang di halaman ini. Cuma kalau misalkan kalian nanti pengen tanya-tanya, kita juga ada Telegram group, jadi nanti bisa tanya aja Telegram ini. Terus kalau misalkan kita juga terima donasi, kalau kalian mau donasi bisa langsung ke sini. Nah, si community space sendiri kita sebelumnya ada di Cikini. Jadi sebenarnya udah satu tahun nih kita udah ada community space seperti ini. Dan community space ini sebenarnya adalah bukan kantor Mozilla. Jadi kita nggak melakukan bisnis di sini. Namanya juga community space. Jadi space di sini, ruangan di sini sebenarnya dipakai oleh komunitas kita. Dan bahkan kalau misalkan kalian punya komunitas nih yang misinya satu jalan sama Mozilla, kayak mungkin bergerak di bidang open source atau teknologi, kalian juga sebenarnya bisa pakai ruang ini kalau misalkan kalian mau ngadain acara sama komunitas kalian. Nah nanti kalau misalkan dan kita juga karena kita semuanya volunteer, yang ngejagain juga ganti-gantian, karena bukan nggak dibayar kan kita. Jadi yang ngejagain itu kita sebut namanya team holder. Nanti kalau misalkan kalian di sini pasti bakalan ketemu dari salah satu orang ini. Nanti bisa dilihat sendiri kalau ada di space, ada di website. Nah ini ada 3 form. Nanti kalau kalian pengen datang ke sini, misalkan Mbak, aku pengen numpang kerja dong, sama nanya-nanya sama Mbak Rara misalkan tadi. Nanti kalian bisa pilih yang registration yang pakai space-nya gitu, kalian bisa jelasin acaranya itu apa lewat form yang disebutkan. Kalau survei itu kalau misalkan kalian setelah acara ini misalkan ada komplain Mbak, makan ini kurang banyak nih, atau space-nya kotor atau apa gitu, misalkan kalian bisa komplain lewat form survei ini. Dan kita juga ada di sosial media, jadi kalau misalkan kalian pengen tahu update-update kegiatan kita, bisa langsung follow aja kita gitu aja sih. Ya. Okay, so Faki, are you ready? Yeah, the floor is yours now. Thank you. Sedikit introduksi tentang Faki ini. Jadi Faki itu salah satu Mozillian dari Hungaria. Jadi sebenarnya kita nggak bayar dia untuk datang ke sini, cuma karena dia lagi liburan di Singapura, kita suruh main dong ke Jakarta terus ngisi kelas. Terus akhirnya karena dia juga mau, ya udah akhirnya.
Kayak agak terpaksa deh.
Oh iya, dan dia juga punya anak namanya Bella.
Yeah, so hello everybody.
Hello.
My name is Ishvan Smojanski. That sounds cool. But also Fluffy is just fine. So I'm Brazilian. As Kiki said, I've been around. I'm in Asia. I'm from Hungary, in Europe. I'm from Budapest. But I was visiting some friends in Singapore and doing the conference out here. I have to visit my Indonesian friends.
I have to. You don't want to?
Like made me. Like, sorry, you have to go. I'm like, oh, that's okay. No, really. So I was like, no, it's good opportunity. So, and I'm going to be talking about Rust, which is a new programming language invented inside Mozilla almost 10 years ago. I will tell the story. And it's just a short introduction to what is this thing that's called Rust, and what you should know about it, and why you should know about it. So that's okay. You're never gonna get the cat out or the fox out. So about me, I'm a JavaScript developer and web developer. As I said, I'm from Hungary, but I mostly spend my days traveling and speaking. I'm a Mozilla speaker. This is what you see on here on Wiki. This is the logo of the Mozilla Speakers program. It is basically Mozilla helping speakers around the world to talk about Mozilla technologies or open web. Mozilla supports these people with trainings and resources and sponsoring. I also teach web development back in Hungary, and I teach workshops, and I do consulting on web development, all kinds of web development. You can find my Twitter handle there. Feel free to tweet at me if you have any questions or need to ask something. I'm happy to try and answer for you. Also, it says I'm a hardware hacker. Some of us who might have been here yesterday might have seen my talk about the JavaScript games on the microcontrollers. So also do a lot of stuff in world microcontrollers. So what is this Rust kind of thing? Who have heard of Rust here? Like other, besides seeing the Instagram, diversion. All right. So who has heard of JavaScript here? JavaScript? No. Who has heard of C or C++, the programming language? Okay, a few people. So basically, when you think about programming, there are two very big groups of languages. There are a lot of ways to group languages, programming languages in general, but there are two very big groups. One is high-level languages, and the other one is low-level languages. What it refers to being high-level or low-level, it means how close to the actual machine, the actual computer, or even the processor or the central processor, how close the language is to whatever finally gets executed on the machine. So your computer has a central processing unit, the CPU, a processor, that executes all the things that happen on the machine. It has a lot of different other hardware as well, but the CPU is one of the most important. That's why it's called central processing unit. So the CPU actually consists of millions and millions, like these days, it's billions of little logic gates and transistors. How you make the CPU do something is it has a very low level language that can manipulate numbers and data, basically. So this very low level language is the codes, the operational codes of the given CPU. And there is a slightly bigger abstraction about this that's called assembly or machine code. That is basically the very low level commands that you can give to a processor. The languages, the programming languages that you don't want to program your computer in assembly because it's very tedious work and it's very low level, it's very hard to understand. We have been talking about this yesterday, like the very early computers were almost exclusively programmed in this assembly language. We have been talking about the Game Boys and the very first like Nintendos and Game Boys. Those are also all programmed in assembly language, which basically means the very low level language that you have to access the memory banks, the data in the memory of the computer manually. You pull bytes out of it, you pull little bits of data out of it. And people soon realized, especially as computers got more powerful, that they need a more higher level. So that higher level language almost exclusively became the C language. C language, like the C as the C character, became the very first language that people started making programs in and started making operating systems. So that's why these languages are also called these very low-level languages that are in the same family as C. And there are a few others like Fortran and COBOL that are less used or used in very specific places like banks, inside banks. COBOL is still a much used language, but most of the people don't learn, they don't teach COBOL in universities these days. So these people who can still program in COBOL, they are very, very popular and they have made a lot of money. But there came the C language, and if you haven't heard of it, basically the C language makes the very basics of the Linux kernel. So the Linux operating systems, back in the days, initially the Unix operating system was basically made in C and created, programmed in C the same. It made the basis of the very central core of the Linux operating systems is still today programmed in C code. So there came a extension to the C++, to the C language called C++. C++, if you ever heard of object-oriented languages, C++ is the object-oriented extension to the C programming language. So you can not just have structures and raw pointers like you could have in C, but also you could have much higher level objects, classes of objects, and inheritance. This C++ became the de facto standard of a lot of low-level things. So if you look at games, most of the games are today programmed in C++ as well. So most of the games you are playing are programmed in C++. Firefox, the browser, for example, most of Firefox's code is also in C++. So V8, the JavaScript engine powering Chrome, and Chrome itself, of course, or Node.js, are all these programs are created and written in C++. C and C++ are systems or low-level languages, and what you mean by that is you have an operating system that gives you certain powers, and the C or C++ has a very low-level access to anything that the operating system provides you. The operating system provides you access to the file system, so your program can read and write the files that are contained on the hard drive, and gives you access to all parts of the computer. In C and C++, you get a very low-level access to this. That means you can access the memory, you can access the file system using this very low-level commands. And what that means is basically you can have a very large and very extensive control over how you write your program. You can go down to the very details and write your own memory management routines and write your own memory or your own very low-level code. You can even embed assembly code to make your program faster in C or C++. What this gets you is a huge flexibility. You can implement whatever you wanted. What it also gets you is big performance. You kind of fine-tune the very details of your program and make sure it executes at the maximum top speed. There is also no runtime in these languages, which I'm going to be talking about a little bit later. That means there is nothing besides your program to slow your program down. When we make a jump and talk about what a high-level language is, high-level languages are a lot of other languages that you might know from around the web development scene that run up above all these other applications are generally not used to create operating systems or very low-level programs. What they are used for is to create user programs or web servers or web pages. So one of the very popular high-level languages is Ruby, for example, or Python is very similar. What these languages get you is you don't have to worry about the very details of creating a variable, allocating some memory, putting some strings or some data in there. But they will manage this for you. This is why they are called managed languages, because they will take care of all this stuff for you in exchange for running a runtime. A runtime is something that takes care of all this stuff while the rest of your code is running. A runtime takes care of allocating memory, freeing up memory, and doing a bunch of housekeeping to make sure all these things happen. So this is the two big groups of languages. One, you get the very fast, very high-speed programs, but you have to do basically everything manually. You have to code every bit of this manually. And where it also comes another drawback, because you have so much power, you know, a lot of power comes with great responsibility. So you, with all that power, you have to be very careful. Because any problems that you may cause, any issues any bugs in the program, can crash the whole computer. Or if you don't freeze some variable, it's gonna come up later as a problem. On the other hand, there are the high-level languages which you know, hold your hand. They take care of all these problems, all the memory allocation, all the freeing up the memory space until you're done with it, and basically help you worry about your program more than worry about the low-level details. But because they are gonna do this housekeeping for you, and because they restrict you, you cannot have all the flexibility, you cannot have all the low-level access. They are essentially going to be slower than your program will be executed. Sometimes this is okay, but sometimes you want to have more power and more speed while still retaining some of the flexibility and some of the ease of use that these high-level languages give. So when you think about, for example, you think about JavaScript, now you can run JavaScript using Node.js. You can use JavaScript as a language to execute on the server or on the low-level devices. But it's going to be slower if you write a web server in JavaScript than if you wrote a web server in C or C++. If you wrote a web server in Node.js, or you used Apache or Nginx for your website, one is going to be slower than the other, and the Node.js version is going to be slower than the other, because one is using a low-level language that is very optimized, while the other is using a high-level language. Where you get what you get with using Node.js one in exchange for some of the lost performance, you'll get flexibility of you being able to find to figure out what your web server needs to do or not doesn't need to do, and you can customize it in any way you want. Okay, so we now know that there are low-level systems languages and there are high-level managed languages. Where does Rust comes in? So Rust actually comes in right in the middle of those, but closer to the low-level languages. Rust is a systems programming language. That means it is very close to the system. It is very close to the bare metal. And it actually has no management system, so it actually has no runtime. So that means that it is capable of the same speed that C or C++ programs are capable of. What it also comes with comes with a compiler that is focused on making your code safe, fast, and making it easy for you to create programs that execute parallel. That means that use multiple threads, that we now more and more have our computers have multiple processing units executing code at the same time. So how does it do that? I mean, if it makes perfect sense. If one has like fast speed and the other has big safety and like big convenience benefit, I mean, why didn't somebody come up with this earlier? And I'm going to be telling you a few features of Rust that was used and that was explicitly designed so it can like meld these both two words together. So this is Steve Plotnick, and I'm also going to share the slides. So the slides have a lot of links in there. So if I piqued your curiosity, you should check out the slides later. There's going to be a link on there. And there are some very good videos. I'm not going to be talking about how you program in Rust, because we're going to have different sessions for that. I'm just gonna try to explain you why you should care about Rust in the first place. So this slide actually links to a video that is about Rust's history. It's like an hour-long video, and Steve Klebnik goes through the whole evolution of Rust and how it became the language that it actually finally became. Steve Klebnik, by the way, works with Mozilla. He works on the Rust team. He writes most of the documentation. But what is also interesting about knowing about him is that he was actually a very well-known Ruby programmer. So he was programming Ruby for a very long time before he switched to Rust, and now he does a lot of Rust stuff for Mozilla. So as I said, Rust is almost 10 years old. The very first bits of the language landed before 2010. And it was created by a person called Graydon Moore. The guy was actually working at Mozilla, but he was working on this programming language in his free time. And he worked on Rust for 4 or 5 years in his free time, not really telling anybody about it. While he actually at some point he went to Mozilla and he put together a slide deck. There's a link to the slide deck later. So Graydon puts together a slide deck to show Mozilla what was the language he was working on. And he was like, I wanted to create a programming language that had all the speed and performance benefits that C or C++ had, but something that was safe to use. Even today, I'm going to be talking about this, even today, the most experienced C++ programmers still make mistakes because they are also humans. And Graydon wanted to make sure that they catch all the problems that could be caught before you compile and run your program. So he puts together the presentation, he stands in front of Mozilla, and they actually saw that this was a great opportunity and a great thing. So they created a whole new team in the Mozilla research and gave Graydon a few people, and they started working, bringing this language to the people and to be usable inside Mozilla and outside of Mozilla. So the language is born inside Mozilla, and they still put a lot of effort in it. But you will see there is a lot more. It is completely open source. The language itself is completely open source. There are a lot of contributors. So there is a lot of things happening outside of Mozilla as well. I even hear some Google engineers. I was talking at some conferences to some Google engineers, and they were like, "Oh man, you wouldn't imagine. I would so love to put some Rust into our code base because it would solve a lot of our problems." So it might happen at some point. We will see. So, but this was all just hacking and trying to get Rust together, and the language was changing all the time. If you watch the video, he will show you code from like 5 years ago that actually doesn't exist anymore. Like it doesn't run on current Rust. So the language was changing a lot. So they realized that we need to get this done. So I need to make this stable so other people can use it. So that's when Rust 1.0 was released 2 years ago, 2015. They were like, okay, so 1.0 means the language is still going to change, but it only is going to change in backwards compatible ways. That means if you start using Rust now, you don't have to worry about having to rewrite your program just to work like in a few weeks because we want you to use it, so we are going to make it more stable. So they released 1.0, and actually what is very funny about Rust is actually they come up with a new release every 6 weeks. Just as Firefox, Rust is actually in a fast release schedule. Like C or JavaScript, for example. JavaScript just switched to a release cadence where every year there appear new JavaScript standards versions. Languages like C or C++ also like maybe release a new version every year. Rust has a new version every 6 weeks. But it's okay because they make sure they actually have a great ecosystem. They have actually packages that users contributed. If you use Node.js, this is very similar to NPM, or very similar to like Pip in Python, for example, or Ruby gems. So they have a central repository, and before a new version of Rust goes online, they actually compile all the thousands and thousands of packages with a new compiler to make sure that everything still works. So it is, not like Jesus. There is a new version of Rust. Is my code still going to work? It's like, oh, there's a new version. Nice, it works still better. So the Rust 1.0 appeared, and people started implementing and started using it, and started trying it. And so, okay, but why? What did Mozilla see like 5 years ago? What did these people see when Graydon showed this new language to them, that they give them a team and bit money and put resources into creating a new language? The answer, whoever have heard of Bound to Own? There's a competition called Bound to Own. It is basically a competition. It's a security competition that tests software and gives people the opportunity to get a big prize if they discover vulnerabilities in software. They every year they have this competition, and every year they test multiple browsers as well as other software. And people who can find zero-day vulnerabilities that are security issues or problems that could be used to take over the computer, to execute some code on your computer. All these people who can come up new bugs in a browser or in a software, they are rewarded with some cash prizes. So the creators of the competition do this to make your software more secure. This is basically white hat hacking. You are asked to try to find the security vulnerabilities in the software, and if you can find some, you will get a prize for it. In 2015, so last year, 2016, they didn't even include Firefox, but 2015 they included Firefox still, and every browser had like 4, 5, 6, 4, 3 vulnerabilities that were discovered in this. Firefox had 6, I think in that time, 6 vulnerabilities, and 4 of them were memory issues, use up to 3 bugs, or bugs like, or issues like this. These problems are generally stemming from they stem from when you're writing a program. You want to use some data. So in C++, you allocate some memory. That means you say, okay, I need 15 bytes to store this string. Later in your program, you're gonna say, okay, I no longer need this memory. So you unallocate it, you free that memory. And for some reason, your code, you still store the variable, the pointer to the variable, and later you will try to read it again. So you already freed that memory space up. The computer already knows that you're not going to need that space. So it might have already reused that space for something else. But you still store a pointer, you still store a reference to that position in the memory, and your program will try to read it back. Or off-by-one errors, when you have like an array, and you try to read past the end of the array or past the end of the string. You have allocated the array that's like 10 elements, and if you try to read the element that is at the 11th location, that is going to be besides what you have been reading before. All these issues come up with C because C lets you do this kind of stuff, because it's part of the flexibility and the speed that C or C++ offers. There are ways to make sure these issues don't happen in C code. but it's very easy to miss these because these happen so often. And these are obviously just some trivial versions of the issue, but you can get an idea. So all these issues that Firefox was found and people were getting access to your machine by just you opening a web page and somebody executing some JavaScript code or some code on the web page, and they would gain access to your computer. They could read your files, install a Trojan, keylog, look for your keystrokes, and discover your passwords just by going to a web page. So these are very serious problems, and 4 out of 6 problems that Firefox had to do with these very trivial problems that are stemming from issues that were used after free process. And this is the exact problem that Rust tries to fix. There is a link to the article if you want to read more about it. And this is an issue that Rust tries to fix. Not all of these problems, but a big chunk of these problems are automatically solved if the code is run by and programmed in Rust. The reason for that is because Rust doesn't let you write code that these kind of issues can appear. There is in the video, I'm going to be showing you an introductory video. There is a very good 10-minute introduction by one of the core team members of Rust who guides you through this, how this works. But basically the idea is you can do this problematic thing. You can create a variable, deallocate it or reallocate it, try to read it back later, and your program will crash if you compile with C++, but your program will compile. So you can compile and create an executable problem that has a very trivial issue inside. When you create the whole, when you try to do the same thing in managed languages like Ruby or Python, they will make sure these issues don't cause problems. How Rust does it, Rust cannot make sure that you are not accessing memory that you don't have access to, because Rust cannot do that. Because it doesn't have the runtime and it doesn't handle all your memory management. What Rust can do is when you create your program and you try to compile it to an executable file, it will actually spot these problems. This is because the language is built around making sure these problems don't appear. So what Rust actually sees, the compiler sees that, hey, you actually made some mistakes and these things are going to lead to problems. It will actually let you know that, hey, this won't work. This is not what you think it will do. This is actually going to cause problems. So you cannot compile the problem. Rust will not create the executable file until you fix those issues. This will let you do problems that will fix a majority of these issues with memory management. And the other big part of it is data races and shared data. So what data races are, if you imagine how a program works, is you have 3 buckets and you try, if you have 3 buckets and you try to, like 3 arrays, and you try to calculate how many items are in one array. So what you will do is you will use 3 different processors to do this. And how you usually do count stuff, you're like, okay, there is now, here's 1 apple in the bucket, so I'm gonna see what's written on the notebook. Okay, the number 5 is written, so there is 5 apples, so I'm gonna cross it off and write 6. And then you throw away the apple or give it to your friend, and you start counting the next apple. Now think about it, how you would do it if there were 3 people in the room. So what could actually happen is actually you take an apple. Okay, I got an apple. I'm gonna take the notebook. The number 5 is on the notebook. You put back the notebook,
you give your apple to the person, and you you get the notebook and write 6 instead. But somebody next to you might have actually taken the notebook as well. So you both read 5 on the notebook. By the time you update it with 6, actually what you should have updated it with should be 7, because the person next to you has also seen 5, and they're also going to put 6 on there. So the problem with this happens all the time in computer science and code data races, is when you have a shared resource that you are trying to access from multiple places. And it's becoming more and more a problem, because we are going to have computers that have a lot more processors and a lot more CPU cores. Like even the mobile phones, like having a mobile phone that has 4 or 6 or 8 cores even, is not an unusual sign. So, because we have this, Rust actually, this is very hard to do also in C++. You can do it, but it becomes problematic. So Rust also tries to cater and tries to save you from all these kind of issues when you're accessing a shared resource from multiple different threads, different sources running in your code, making sure these kind of issues don't happen. This is what I'm talking about. So this is called shared mutable state. That is, the notebook is a shared mutable state because something that is shared between friends that all friends can access and can modify as well. So if you want to learn more how all this works, like I can recommend you, there's a screencast series called Into Rust by Nikos Matsakis, who's also part of the core team. It's intorust.com. You can just go to the website, and there are all these like short 5 to 10 minute videos that you can. There is the very first one is the introductory one. It's basically explaining what I just told you, how this works, that Rust can make sure that these problems do not happen. So I can very much recommend, if there is only one thing you watch after this talk, it should be this intro video. And if you actually liked the intro Rust kind of thing, there is a Rust learning documentation. It's a GitHub repo that has a boatload of different informations, videos collected, screencasts, podcasts, articles that are all about learning more about Rust, getting into Rust, and learning how it does the thing. So if you actually like what was in the video, I can recommend you check this out. And so I told you 2015 Rust goes 1.0. And people slowly, now that the language is actually super, the language is there, it is starting to be more stable. More and more libraries appear on Cargo, on Crazy.io, the package repository for the language. People start using it. So who here uses Firefox? Not as exclusively, but who here uses Firefox as a browser? Has it installed in their computer? Oh, alright. So there are a few people. Alright. So if you have used Firefox, you actually been running something that has Rust code built into it. Until after Firefox version 45, I think, there's already Rust code running into your browser. There's already Rust code that helps Firefox. There's a media stream splitter that helps Firefox play back videos that originally was C++ as well, but they replaced it with a Rust version. And actually what they did, they actually ran the two parallel. So you actually had the Rust code in there and the C++ code in there. So they used the 200 million people using Firefox. And all the internet content, all the video content of the internet to actually test this feature. Because when the very first moment they landed this Rust code into the browser, they actually ran the code in C++, they ran the code in Rust as well, and they actually compared if the output was the same. And there was actually 1 billion, that's 1,000 million executions, and it got 100% right. So the Rust code that was running inside the browser was tested in all your machines. If you were running Firefox back in those days, you were actually helping Mozilla test if Rust actually worked well in the browser. Because Firefox has like 4.5 million lines of code. You cannot just throw it away and start again and write the whole thing again in Rust, right? So Mozilla had to come up with some method to make sure that they're going to have a more secure browser. They wanted to use Rust in there, but they could not just rewrite the whole browser. So they were like, okay, so what we are going to do is we are going to do something that is called, we're going to modularly replace some of the parts in Firefox with Rust code. And why this actually works is because they already have some Rust code that was made for a web browser, and that Rust code is called Servo. Servo is an experimental browser completely written in Rust. So they were like, okay, we have Firefox, we're going to start experimenting and start creating a browser engine. Servo is basically, Firefox has the browser engine called Gecko, and Servo was made to be a browser engine just like Gecko. Chrome has its own browser engine called Blink. Safari has its own browser engine called WebKit. So all these browsers have a browser engine that is responsible for showing you the web content that is on the site. There are some other components of a browser, like the JavaScript engine, for example, that are besides the browser engine. The browser engine makes sure the HTML and CSS, those stuff you can get from the browser. And so people at Mozilla Research started working with this Servo, which is coincidentally one of the names of the kittens in the Mozilla space, just so you know. So Servo is this project, and they started from the ground up, they started working on a web browser, they started experimenting. And it is blazing fast. Like I could tell you, because it can use all your machine scores. Servo can actually do parallel layout, which is there is a picture. I will try to find it for you later. It basically is Reddit, a website, and all the parts of the web page have these little colorful rectangles around them. And each color means that this layout, this portion of the web page was actually laid out by a separate core in your computer. So if you have a 4-core computer, these things are created parallel. That means all of these chunks independently are laid out, independently of each other, are laid out using all the processing power of your computer, instead of just throwing all this work onto one core of your machine. Because of this, because of Rust in general, and because of some of this stuff, Servo is super fast. They actually decided, hey, so we have this super fast research browser. So what we are going to do is we're going to pull some parts of it and try to integrate it back into Firefox. So before we have a complete and fully functional browser, we actually are going to use our complete and fully functional, but a bit slow and a bit, bit insecure browser. We are going to replace it parts by parts. So when you use Firefox, you still get the extras, the security improvements and the speed improvements, but they actually figure out how to do the whole thing in Rust. So even to date, you already have some basic Rust code, like the URL parser that uses used by Firefox is also Rust now. But what comes now is the new version of Firefox, 57, that comes out in November. Actually, it's going to have the CSS engine. It's going to be ported from that's called Stylo, and the web rendering part of Servo is going to be ported from Servo to Firefox. And if you use Firefox nightly, you can already see some of these improvements. Like Firefox, the new style engine actually is 2 to 3 times faster than the old style engine in Firefox. And the style engine is just one part of Firefox. So your Firefox won't be 2 to 3 times faster just because of this one, but it's going to be noticeable faster. And all the other parts are slowly coming in as well. So if you use nightly, you're going to see those changes earlier, but if you use normal Firefox, you will see those improvements in November. But Mozilla, like I said, Mozilla is, Rust comes from Mozilla, but it's not the only place where Rust is used. You might have seen an article about Dropbox. Dropbox actually, they were using Amazon's cloud infrastructure for their storage. So Dropbox is this company that you can install on your computer, and it synchronizes your data up to the cloud. So it can serve as a backup, and it can serve as, your folders are shared with other devices when you install Dropbox. So if you use Google Drive or Microsoft, what is that? Drive something. It is very much the same idea. So you can have your files in the cloud, stored in the cloud, on your computer, and all your other devices you can access them. And they were using Amazon's online infrastructure to store all this data. And they got big enough that this was actually more expensive than building your own specialized cloud infrastructure. So what they did actually, they built their own cloud infrastructure. And they did this, I think, last November, December, something like end of last year. But they only announced it like this May. And why they did that is actually, hey, we completely migrated all your data into our personal and highly customized custom infrastructure. And the world hasn't ended. Like everything is still okay. Like nobody noticed, basically. And so they were like, okay, so we migrated all this data, and we rewrote the very basics of our system in Go, which is Google's new programming language. But here comes the twist. Actually, they wrote a new file system, and the new file system is actually implemented in Rust. So Go actually calls Rust code when it accesses the file system, and the whole file system is the very base of the whole new infrastructure. So in the very core of the infrastructure is still Rust, and on top of it, it's Go. Go is a bit more higher level than Rust, and then all the other languages. And NPM, which is the Node, the package system for Node, actually they rewrote some of their own core processes in Rust. And it goes on, the list goes on. People are making, there is a whole blog series, how to create your own personal operating system in Rust. And Steve also talks about this, that you can just require, you can include a package that will get you the x86 processor system calls that there are no way to do any other way, just in ASM assembly. They will wrap those calls, and you can just use it as a Rust function. So there is a whole blog post, I think it's like 12 blogs, 12 posts already, and they let you know, okay, so your machine boots up, but you have to implement like keyboard, and you have to implement like memory management, like paging, and like all these super low-level stuff that the Linux kernel or the Windows kernel or the operating system kernel gives you, or file system access. Like you can implement it all in Rust, and you can do it. Like you, as in any of you, can do it because there is a whole blog post series that you can go through and manually create your own operating system. And it's not just your toy operating system that you can create, but people are actually making new operating systems to use Rust. The next gen OS link, you can see a link to Redux OS, which is a IoT operating system made for IoT devices. Because again, IoT is super insecure. Everybody knows that the S in IoT means security, right? There's no S in IoT. So So because of this, and because of you want to make sure your program is energy efficient. You want to make sure your program is secure. Rust is a very good choice. If you look people doing cryptography, if you look at people doing blockchain or doing all kinds of cryptocurrencies, if you're looking people doing AI work, all these people are using more and more of Rust because this is what Rust is good at. And the list goes on. There is a whole friends page on the Rust language's homepage that you can check, and you can see all these companies, Telenor Digital, and like all these companies that use Rust currently live in production in their live system. Like their software, their money, the whole existence of the company hangs on the Rust code working. And so there's a shameless plug. So I'm actually, like I said, I work a lot with Mozilla, but what we also do is also organize a conference. This conference is called Rustfest Zurich. The conference is called Rustfest, and it happens 2 times every year. At least so far, it happened 2 times. Our main problem was that Rust only had 1 conference, and even that 1 conference, the original Rust conference, usually happens in the US. And there was there's now another conference called MozBelajar, but that's also in the US. And me and some friends actually decided that there is a huge community of Rust actually in Berlin, in Germany in general. There are a lot of Rust people in France, in London, in Switzerland. There are a lot of Rust people actually that would love to know more. Like conferences are to get together, talk to people, introduce people what you were doing. So we decided to do a conference that is going to be Rustfest to cater for all these people in Europe. And we did one in Berlin, and then we did one in Kiev, and the next one is coming up in Zurich. Why I'm telling you this is two things. If you actually work on Rust, or if you know somebody who works on Rust, we have a call for proposals, a CFP open. That is, if you're going to submit a proposal, a talk proposal to the conference, and if your proposal is about something that the committee wants to hear of, we're going to review all the proposals in August. If we accept your proposal or your friend's proposal, then we pay your travel and we pay your accommodation in Zurich. We will help you get a visa. So we'll make sure that you can present your idea or you can present your talk on Rust. So even if you yourself don't work with Rust, but you have a friend who you know they made a nice and cool stuff, please tell us that and please encourage them to submit. Because the conference is based in Zurich. The conference itself is based in Europe, but we definitely don't just want people to present there who are from Europe. So feel free to submit to the conference. And there is one more thing why I'm telling you this, is because since we started a year ago with Rustfest, actually people have been coming up to us. And the Zurich version actually takes place because somebody a year ago from Zurich came to the conference that we organized in Berlin, and after the conference they said they wanted to go do a Rust conference in their home country as well. And so what happened is that we started talking, and the next version of Rustfest is going to be in Zurich, with them helping us make it a reality. Same thing happened a few months later. Somebody came up to us and they started helping us with the second edition of the conference, and they said that they wanted to make a conference in their hometown in Amsterdam. So we were like, okay, trying to organize it, and we'll help. So now it looks like the next conference might actually be in Amsterdam. We are actually looking for venues, and we are helping them to create their own conference. And why I'm telling you this is because since then we actually heard from people from Peru, heard from people from China, from all the different places that they wanted to do their own Rust conference. So where you come in this is that means, you know, if there isn't a conference in Indonesia or Asia, you can create one, and we are happy to support you and sponsor you and help you with our people, help you with our knowledge. So if you wanted a Rust conference to happen in your area, you can make it happen, and we'll be happy to help you, connect you to the people that can help you with this. This is also important because now in the exact perfect place to learn more about Rust, because Kiki is not here, but they will be organizing another Rust meetup, and what is it? Oh, they will be organizing another Rust meetup, and there might even be trainings that you can learn if you haven't gotten to it, or you have friends who you wanted to introduce the language to. They might even happen to have some workshops and trainings that you can learn the basics of the language. So because of that, everybody is welcome to do this. But even if you started learning yourself online on IRC, there are a whole lot of helping people that are happy to help you if you come across with any issues and problems that you have. So I think that was mostly it. Oh yeah, because that's the back end. Okay, so thank you for listening. There's my Twitter handle if you have any questions later, if you wanted to ask me. And you will find the slides on talk.thug.is/rust. Just enter that into your browser and you will see the slides, and you can see all the links that are in the slides. And those are my tech speaker buddies from yesterday, and our Fox buddies as well. So our Foxy buddies and my tech speaker buddies, Terry Makashi. Thank you for listening. Okay, if anybody has any questions that you think the others might be interested in, feel free to ask. If not, you can still ask me personally after the talk. Any questions?
Can Rust manipulate the DOM?
Very good question. So the question was, can Rust manipulate the DOM in a web page? So the fun fact about this, there is actually, if I go back, there is the backends and frontends link. If you go in there, one of my conference co-organizers and one of my very good friends, Jan Erik, he actually gave a talk on this. So what he did, there is a Rust library. There are several Rust libraries that lets you create a web server. Several different libraries that exist for this, but basically you can create a web server in Rust that is very performant, and it's quite as easy, just almost as easy to program as, like, for example, an Node.js web server. So with that, you can do that. You can serve from a web page. You can serve from a web page. You can serve from a web server. You can serve a web page. When that web page arrives to the client machine, you want to do some client-side work. These client-side work you usually do in JavaScript. So that's why you write your HTML, your CSS, and your JavaScript that you use a web server to deliver to the client. Now actually there are front-end libraries to Rust as well. What basically these do is they create an abstraction layer, so you can write your front-end code in Rust and they compile it to JavaScript. So when it actually sent to your client device, you write Rust code, but the client will receive a translated version of it that is actually written in JavaScript, so your browser can understand it. So you can write your backend code that sends your web pages and resources to the client, to the browser. And you can write your front-end code that executes all these code in the browser. And what is even funnier than this is I told you about the servo project. So if you look at the talk, I can recommend it. It's a very hilarious talk. So you now have the backend server. You can set web pages. You can have the front-end application in Rust as well. So you can create the client side, the in-browser, the workings of your web page in Rust. And what he also did is he actually put this onto a Firefox OS device back in the days that wasn't running Firefox's Gecko engine, the original engine, but it was actually running Servo. So your hardware is running a web browser that was written in Rust, gets the data, gets the resources, the web page from a server that was written in Rust, and all the data that arrives to the web browser that is written in Rust is actually written in Rust. All the JavaScript code is actually written in Rust and compiled to JavaScript. So on all different layers, it actually was Rust. It's a very crazy experiment. I don't recommend anybody doing this. But actually, yes, you can just you can do backend, frontend, and low-level in Rust as well. I'm not saying you should, but you could. Okay, any more questions maybe? All right.
Is Rust supporting any machine learning?
Oh yeah. So the question was if Rust supports any machine learning. My dear friend, also a Mozilla tech speaker from India, from Bangladesh, I could be, Vigneshwar, he actually works with machine learning and AI with Rust, and he actually gives several talks on this. So, like I said, a lot of these machine learning is very dependent on performance. Cryptography is very dependent on performance and security. So all these are very good choices if you wanted to play around the Rust because of the inherent guarantees that Rust gives you.
For machine learning, maybe you can check rwlearningyet.com. That's machine learning.
What is that again?
rwlearningyet.com.
rwlearningyet.com. Okay, last question. Okay.
How fast is Rust compared with C or C++? I mean, you have benchmark or something like that.
So again, if you watch this video, actually Nikos shows you a live benchmark. The code that is written in C is basically 10 times faster as the Ruby code, so the managed language code. So then he rewrites the same code in Rust, and it's basically as fast as the C code that it's written, except it's more secure. So you will see, and so what in the talk he also says that there is a slow C code. That they got there is a slow C code for detecting blank strings that entirely consist of white space. And there was this C++ expert who were like, actually they discovered that this actually blank detection was using a lot of computing power because it was used very frequently, and it was pretty slow because it was using a regular expression. So they got this C++ expert who actually makes a very complicated code, a very unreadable code out of this, and writes this very complicated code that performs like this, like 10 times faster than the managed code version. And then they write this whole code in like basically 5 lines of Rust, and it performs the same as the C++ code rewritten by a C++ expert. So this is the I'm not saying this always happens. I'm not saying like Rust is better than C, but it can be just as fast as C code, and it can be more secure than C code while being just as fast as C code. All right. Yeah, I recommend you going to for the slides, and thank you for listening again, and enjoy the rest of the afternoon. If you still have questions, feel free to ask me after this or thank you.
Terima kasih. Seperti biasa setelah acara kita selalu adain survei biar Mozilla Community Space ini jadi makin bagus. Untuk mengisi survei di mozilla.org/space/survey. Terus seperti biasa juga setiap akhir acara kita selalu ngelakuin foto bareng dan nempel post-it di depan, jadi biar makin ramai. Ya mungkin sekarang bisa foto bareng gitu. Boleh, serah. Foto bareng dulu aja. Background biasa di sini. Mungkin fotonya bisa di sini, jadi ini backgroundnya.
Di balik apa di depan tulisan Mozilla itu. Kenapa kalian? Masih kayak ngantuk ya?
Bisa boleh pakai properti biar makin kan.
Oh.
Yes.
Awas jatuh. Udah jatuh.
Let me just make sure my proper position here.
Soalnya nggak bisa semua. Oh, iya.
And the fox here.
Boxing bisa kelihatan.
Ayo.
Ayo, kita buruan. Oh ini, kayaknya cuma sampai Mas yang baju putih deh, jadi lebih Ina lebih ke kan yang baju merah baru mungkin bisa dibawa bareng kita. Masih kurang. Terus lagi.
Oke,
Just get away. Correct. There.
lagi 1 2 3 ya 1 2 3 angkat tangan 1 2 3 1 2 3 ada yang panggil Fox lagi jangan terlalu tinggi Foxnya ya 1 2 3 taruh tangannya
Aduh, kalau belum gerak satu mau udah gua.
apa lagi yang masih mau naikkan kopi dulu biar nggak ngantuk post-it
Oh iya lupa lagi. Ya biar makin ramai antara di depan ngisi kesan-kesan atau apapun lah.
kita tempelnya di depan ini kayaknya tuh
Udah ngisi bro. Apa nih? Akun Instagram.
Tulis terserah sih saran-saran atau saran.
misalnya makanannya kurang nggak ada makanan
Dapat baju.
Boleh bisa aja.
untuk masuk minuman yang panas pakai yang ini ya yang
Oh iya. Tadi sama dikasih semua.
Balik.
Mau narsis juga boleh saya keren dong telepon saya ya ada kan di situ
Oh yeah, you need to write the wall.
Oh, okay. Oh yeah. Getting a bit stuffy. My text is
Gak bawa lagi mode bukan Jakarta Mozilla.
Yang nyata.
I just realized that I was thinking this morning that that's okay. I guess I have
Itu mau stikernya?
Yes, you forgot. You were careful.
this
Can I draw you a text picture?
Kalau udah semua juga boleh.
Can I draw you a text picture?
Enggak cerita.
Nggak baru datang.
Bagus sih.
Belum
Aku mau gerak.
Kalau internal mix startup
Iya, kan project kita dari tempat banyak banget yang di itu
Dia
jalan-jalan
And I can write stuff, sure, but that's boring, you know?
Ini kalau mau voting silakan.
kalau di dalamnya pernah. Iya. Karena ada 3 orang sih yang mau
ada juga lagi merasa
Oke. Ini di sini lagi nyari tuh pasar polis.
Jakarta nyari
Weekend. Mananya?
Stikernya boleh Pak.
Nggak tahu aku.
Target.
Maybe boleh.
Tapi nggak pakai itu.
Aku hanya ikutan.
Mereka tuh.
Boleh diambil nggak sih?
Nggak tahu.
kasih
Kamu boleh sih.
Boleh dibawa.
Boleh boleh.
Boleh ya?
Ambil beberapa boleh.
Habis juga.
Enggak, ya mau habis sih.
Satu lagi juga. Habis semua. Ya udah.
Yeah, you're welcome. Like topic presentation. What are people talking about? So it's the production age. So like most often that something that comes out is basically this or that concept or this or that products. Like that kind of thing. No, as well is definitely the version of 547 that is with or and stuff for that. Definitely a huge deal for us. Because shipping for 200 days so that's definitely going to be something that is going to be there's something that is going to be interesting so there's that I guess I don't know like mostly and like I said a lot of companies using it for either IoT stuff or blockchain so like something kind of cryptocurrency stuff like you can have last place sponsored by a crypto company or a cryptocurrency company. We call it sponsored like yes. Yeah, they actually hired a bunch of people at the so and even before the last conference was over, we got people to that they were like a different cryptocurrency company. Yes. So that's sponsorship.
Ya,
Oh, so
iya makanya.
because of the speed and the like they're very
Ada lagi tahun Jakarta.
huge difference. They're really secure but also at the same time it's just as fast as
Kamu bisa bikin aja dalam master CS Indo. Jadi jauh-jauh kita nonton aja.
yeah, absolutely. Yeah, so like I said, like, the value can be different for different
Mungkin gitu ya.
for example, cryptocurrency where firm speed
Masih CS
and like that it's really also like because when you're hashing you're doing all this like super you want to make sure that all your computer cores or all your GPU cores or all your machine is completely visualized. So that all these like measuring some people were using it for reliability. Some people using it embedded. A lot of people writing actually add-ons for language languages. Like you can write like they're using Rust Java. In Ruby they're using the Ruby Java that is actually using Rust. Because earlier like previously you could do like for Node.js or Ruby, right? You could write native add-ons. The functionality is exposed to the Ruby or Python by separate. But actually Rust native. And you can do that with C or C++, but it's not very easy to do because of the old problems with C. So people are going to get switching to Rust.
You have to do this happen in Jakarta. Right? You need some GPM. And then you can what type of architecture
What kind of architecture?
ada yang
Yeah, expensive, but not having the basic things that the code is implemented actually code in the language. And it just not just so it doesn't so like Java has their own library that is here, but they are not by in JVM virtual machine. So then it has this library to be in presentation. But there are other languages like Ruby. Actually, they are running the code like compiling it actually today, so they don't create any like it's just not the code that you created, but they still manage languages, which means some of the code that you call actually calls out to a process that is run by the execution context, execution context, and manages memory. So actually, the most curious thing about this is usually the management application that you want to run. Java has its own logic, but it's inside the JVM. Ruby, like JavaScript has their own language Rust had a garbage for a long time. So now what you do is you can still use the heap in Rust, but what you do is basically there is a extended library feature in Rust that's called the RCMR, which is basically reference counting. So you can create like a wrapper object that counts the references to the object, and you know when, and it knows when to free the object out and when it goes out of scope. But basically, it can know that nobody's references to the object anymore. You can see the object. It's not here. Nothing here to be but it also doesn't have to have actually they added garbage but they really do they're not building a standard library so that you don't have to base on yourself if you want to use it. Sometimes it's easier and sometimes it's less easy. But basically you don't have to. The idea is that you don't have to.
So basically, Rust is directly compatible.
Yeah. But they actually have very good cross platforms. So it works from Linux, Windows, and macOS, and Android as well. So you can use Yeah. So there's even like a big push now that people to work on Rust and Serval and Visual to work out the languages. Because most of the people who work Rust and Mozilla, they are using Linux so they needed some more there is no way to just like slice it like this, but it's like yeah, so there's the Northwest Sword is sponsored by flight sponsors are Verity who actually work on
Is there any specific partner like the quality that has the IC banner?
I don't know. I don't know if they have like any specific ones. I know hardware. It's just it's basically a single board.